Welcome to Chibuzor Mathphysics. I welcome you to the second series of sequence. We are proving that a certain sequence is convergence or divergence. If you are joining us, you can start from the first video where I introduce what is a sequence, how can you know that a sequence is convergent, and how can you know that a sequence is divergent. Just a brief review of what we did last time. I told you that if the limit of that sequence exists, it therefore means that the sequence converge. But if the limit of the sequence does not exist, it means that the sequence diverge. At any point in time, you pause the video and try to follow and do it yourself so that it will become more retained in your memory. And don't forget to subscribe to this channel so that you'll be notified as I upload subsequent videos. So let us see what we have here. You have been given a question that the limit as n turns to infinity of this number n plus 2 divided by 3n plus 5 is equals to 1 over 3. And this is our limit. So we have been given the limit. This means that the sequence converge because the limit exists. The limit is 1 over 3. So we are going to use the definition of convergence. So we start by the definition. By the definition, this just short form of writing definition of convergence. By the definition of convergence, we know that epsilon must be greater than 0. And if epsilon is greater than 0 for all n to be a member of this natural number n, which is an integer, such that epsilon alpha n minus alpha, which is the limit, is less than epsilon. And if this is less than epsilon, it tells you that for all small n must be greater than big N. So this is all we need to do. Epsilon must be greater than 0 for all n to be a member of this real number n, such that alpha n minus alpha will be greater than epsilon for all small n to be greater than capital N. And that is all required for us to prove and show that this is convergent. So we'll be using this formula: alpha n minus alpha is less than epsilon. So we take this and replace to that equation. That will be n plus 2 divided by 3n plus 5 minus our limit is 1 over 3, and this must be less than epsilon. That is the first step. This must be less than epsilon. And if this is less than epsilon, what it tells you, it implies that you distribute this. 3 by this will give you 3n plus 6 minus 3n minus 5. Because when you take it upward, it becomes negative sign. This will be divided by 3 into 3n plus 5. And this also must be less than epsilon. This is abstract mathematics, and you just need to follow what we are doing, and you will get to understand why we say that a limit of a sequence converges at a certain point. Epsilon. Epsilon is that number that is in between another number. You know, between a rational and irrational number, there exists an epsilon. So let us see what we are supposed to do from here. If you look at our equation, we have 3n plus 6 minus 3n minus 5. So 3n minus 3n will go, and 6 minus 5 will be left with 1. So it is 1 divided by this. So it will imply that this will be 1 divided by 3 into 3n plus 5. And this also is less than epsilon. from what we have, 1 over 3 by this is less than epsilon. So we have, it implies that 1 over 3 epsilon, we try to distribute these. 1 over 3 epsilon is less than 3n plus 5. And this will imply that 1 over 3 epsilon minus 5 is less than 3n. You have to be careful with the inequality sign and the negative sign that I have introduced, because this is positive 5. So when you take positive 5, in order to have 3n in one side, remember that for all small n must be greater than capital N. So we want to have this in one side. So that now you will have distribute this. It implies that 1 over 3 epsilon minus 5 over 3 is also less than n. Is also less than n. At that point, I hope you are following. This is just the trick way of doing reanalysis. In some universities, this is referred to as advanced calculus. You know, you did calculus 1, where you did integrate differentiation. In calculus 2, you did something about integration. And now advanced calculus is what you'll be doing about this sequence real number system, showing that a sequence exists, it converges at some point or diverges at some point. And that's why we introduce infinity and what we call epsilon. But you remember from our definition of convergence, for epsilon must be greater than 0. Epsilon must be greater than 0. So if epsilon is greater than 0, we know that n, which is what we have here, but right now, if you put this will become 9, because you distribute this. So 3 by this is 1 over 9. So it is 1 over 9 epsilon minus 5 over 3. And this is a member of our capital N, which is a real number. Or capital N, which is a real number. And if that is a member of that capital N, which is a real number, it shows that the equation we were given, which is n plus 2 divided by 3n, as it is, divided by 3n plus 5 minus 1 over 3 is less than epsilon. So this simply means that, I don't know if you can still see from here, this simply means that n plus 2 divided by 3n plus 5 minus 1 over 3 is less than, this is less than epsilon. And if this is less than epsilon, it therefore means that the limit as n turns to infinity of n plus 2 divided by 3n plus 5 is equals to 1 over 3. And this is all you needed to do. And we are done with that question. We are done with that question. You go systematically, try to apply the definition of convergence, look at the question and analyze it. If the limit has already been given, it means that it converges. If not, you first of all find the limit of that function, because it is from the limit of the function that you are able to apply in order to prove that the sequence converges at some point. And this is all we do in reanalysis, or what we call advanced calculus in the universities. So I wish you all the best as you try to follow through this step systematically. Do well to subscribe to this channel so that you will be updated as I will post the third series where we look at some more critical analysis on how to see whether a sequence converge or a sequence diverge. God bless you and bye. I remain your friend Galagash.